Hi everyone, this is Introduction to Surjection for Set Theory. A function is a surjection if every element in the codomain has a corresponding element in the domain. And these are also called on-to functions. So let's do some examples. So for example, this function here is a surjection. If you look at the inverse, and you can kind of do the inverse just mentally, if you change the x and y, you'll get x minus 1 divided by 2. So we could say every element in the codomain, remember this is your codomain. This is your domain when you write this out. So domain, codomain. So for every element in the codomain, it corresponds to n minus 1 divided by 2 in the domain. So for example, if let's just do a domain of, let's start with 2. 2, 3, and 4. And you plug that in here. So that's going to be 5, 7, and 9. So this is your domain. This is your codomain. So if you just do the mapping, we have every element accounted for has a piece to go back to. So this 5 goes back to 2, 7 goes back to 3, and 9 goes back to 4, because it corresponds to this in the domain. So this is surjective. All right. This one is not surjective. Every element outside of negative 1, 1 in the codomain, remember sign usually is drawn from 1 to negative 1, something like that. Go backwards. All right. It doesn't have a corresponding element in the domain. For example, if we have sine of x equals 2, has no solution. So the element 2 in the codomain does not have a corresponding element in the domain. And that's if we don't restrict the domain here. So basically, in graphical terms, a function is a surjective if every horizontal line through the graph of the function cuts the graph at least once. So you have to take into consideration the domain and codomain. All right. Right, by restricting the domain from negative 1 to 1, it is a surjection. All right, because we don't have to worry about anything else on the y. So this cuts through the graph at least once. In fact, in this case, we going through 4 times. So this graph would be a surjection, but not outside of that because of this. If you had 2, because 2's in the real numbers of the codomain. All right. I think this is better illustrated by this. So we're looking at surjection. All right. What we notice here is that in our B set, this is our codomain. This is not injective because this element in B maps back to 2 different elements in A. However, it is surjective because each of these elements, 1, 2, 3, 4, 1, 2, 3, 4, has something to map back to. Whereas this one, this is injective because each of these elements has something to map back to, and just one. But this element That would be like our 2 in the sine example doesn't have an element to map back to in the domain. And that's it. Thank you. Have a nice day. Bye-bye.